The endothelium is really difficult to study in humans, let alone in animals. It is, because it's so systemically distributed, as are capillaries and blood vessels throughout the body, and because it's so exquisitely thin, it's not well circumscribed like the liver, like the spleen, like the gallbladder, that it's very difficult to image using conventional radiological techniques, and it's very difficult to assay in the types of ways that we assay other organ functions. So it kind of flies below the clinical radar screen. Clinicians and physicians are trained to think about the heart as an organ and the liver and the lung as an organ, but they're not trained to think about the endothelium and the vasculature as an organ. A second problem relates to the fact that we tend to think as physicians and scientists of the vasculature of blood vessels being comprised largely of arteries, and our focus is on the vessels that we can see with our naked eye and that are important in diseases that cause most of the mortality in the Western world, which are stroke and acute myocardial infarction. So our tendency is to think about large vessels, particularly arteries, which comprise a tiny fraction of the surface area of the endothelium and the mileage of the vasculature throughout the body. And I think the third reason why there's such a gap between bench and bedside in endothelial biomedicine is because the endothelium is incredibly complex. It's very adapted to its environment, so that an endothelial cell in my lung is very different from an endothelial cell in my liver, which is very different from an endothelial cell in my kidney. And that complexity scares people and paralyzes people and makes it very difficult to get one's arms around in terms of defining what an endothelial cell is and defining diagnostic and therapeutic parameters around the endothelium, because every endothelial cell is different. So I think for those three reasons, it flies below the clinical radar screen. We think largely about the arteries and veins and ignore the capillaries, and the third being that it's very adaptive, kind of like a chameleon, that marches to the tune of the local environment. Just makes it an organ that's less familiar to most people.